Yeah, I can see.
So basically, we don't just do like yes or no type of thing. So what we do is we have a bunch of input details, like the distance from the home address of the user, the distance from the last transaction, the ratio between the current purchase and the purchase that just happened, then the previously used retailer if it's the same or not. So just a check mark like yes or no. If the chip card, the PIN, and if it was an online transaction or not. And you input these details and you get a rating on this scale, which gives you like a percentage, right? Like if it happened, like the chance of it being fraudulent, and then gives a recommendation based on the percentage, the probability of fraud.
Okay. Can you put some data and show me?
Yeah. So like 7. So if you put like these two details, right, it gives 100% chance of fraud, and the recommendation is the block transaction and contact cardholder immediately.
Okay, great. So, how accurate do you think your you can put it on presentation mode.
Okay. So yeah, this is my project for the AIML certification. So the problem overview. Oh, sorry. Um. Oh wait, something didn't save. I'll continue. So the overview is according to security.org, 63% of U.S. credit card holders have been victimized by fraud, and 51% have experienced fraud multiple times, and only 1% of these credit card fraud cases have actually been solved. Right. So I don't think my edits have been saved, but what we did is we created a project that helps determine if the um thing is actually fraud, if the transaction, and not just that, but we use a variety of different input factors to give a probability instead of just a binary yes or no. So yeah, and some info on this project. We utilize the dataset from Kaggle, a fraud detection dataset, and this is a Streamlit web application to showcase fraud probability. And this has the ability to process XLSX, XLS, and CSV files, and also able to process a single transaction or a batch transaction from one of these files. So fraud is a classification problem, and we want to predict fraud 1 or not fraud 0. And that's just like a very broad example. And more specifically, we have a probability from 0 to 1, which gives us a percentage. And the goal is to catch the most fraud while keeping just random false alarms low. So we use a probability system. And I input features like distance from home address, distance from last transaction, if PIN chip was used, if it was an online transaction or not, and the ratio between median purchase, like the ratio between the average purchase versus the recent purchase, and just things like that. And the AI will determine if it's fraud or not, and gives a probability of it being a fraud, and then just gives a recommendation based on the probability of fraud. Like for example, this left one, it gave a 48.4% chance of fraud, and it said manually flag for manual review because it isn't too high, but there's still a probability. And then the one on the right is a 1% probability, which says process transaction manually. They don't AI doesn't think that this transaction would be fraud. So yeah. So we got this data from a Kaggle credit card fraud data set, which includes 284,807 transactions, and which 492 in them are fraud cases. And although the data has been cleaned in the fraud set, in the third data set, we still did it ourselves through data cleaning. So we followed the CRISP DM method, which will understand the problem, then explore the data, cleaning and preparing the data with EDA, then building and testing the models through model development and feature engineering, evaluating the results, and then deploying the model through Streamlit. And our project was built using Python, which used pandas and matplotlib for analysis and plots, Sci- scikit-learn for modeling, and I used a little bit of ChatGPT for this, like for the code. I didn't understand this part a little bit. And I used to use ChatGPT to get the code and understand it, so I understand it now. And then Streamlit for building a simple web app to test transactions. So first, the process we used EDA and explored the data and found patterns like online transaction had a lot more fraud, which is pretty self-explanatory, and chip and pin transactions had a lot less fraud because it's hard to obtain those um, info, right? And with model development, we tested multiple models. Although at its core, it's a classification problem, random forest was gave the best results, right, with all different factors. And yeah, so we used the code to build a Streamlit web app where users can upload a CSV file or those other files that I mentioned and get a batch fraud detection of multiple different transactions, or just simply enter one single transaction and the probability of fraud is given. So future steps, like next steps we want to do is add more data and connect to real-time APIs for as there's more potential for better accuracy. Then creating audit logs for the transactions so that users can look back at it. And this is something I thought of recently, but utilizing user feedback to help retrain the model, as this feedback, oh, this was good, oh, this was an inaccurate thing, could help retrain the AI model with feedback and maybe get future more accurate results long term. So yeah, that's all.
Okay.